Something really important in the world of Roblox development is the ability to create reusable systems that you can drop into any game or project you're working on. Learning to design a system that's agnostic, meaning it doesn't care what game it's in. It has no dependencies on game-specific stuff. It's just a drag and drop system that you can reuse across projects. There are already a lot of open source resources built like this. A good example is Topbar Plus. It's a drag and drop module that works across any game, and it's specifically designed to be agnostic with no game-specific dependencies. In this video, I want to dive into this idea and show how you can design a system to be agnostic. I'll be using my module loader as the backbone, and we're going to look at a couple of systems that use my module loader so you can get an idea of how designing a game-agnostic system may look, and we'll create an example on ourselves. I'd also love to hear how you go about designing reusable systems to make your coding more efficient. Let me know in the comments below. And since efficiency is our goal, you can further refine your learning efficiency with the sponsor of today's video, Brilliant. Brilliant helps you excel in math and computer science with visual, interactive problem solving and personalized practice. Brilliant is designed to be highly effective by learning through active problem solving, which has been proven to be more powerful than watching lectures or videos. Brilliant has a perfect mix of interactive problems and encouragement to keep you moving forward and making progress towards leveling up your brain. What's great about Brilliant is that it personalizes your learning. You'll start at the right level based on your background and work your way up through practice sets designed specifically for you. Math can be one of the most difficult areas to learn in, and it's not your fault. It's the way we learn math that can feel confusing, but with Brilliant, you don't just memorize formulas, but you get hands-on with concepts until they make sense. This enables you to develop the intuition and problem-solving skills needed to figure things out on your own. So to get started learning for free, head to brilliant.org/crusherfire, scan the QR code on screen, or click the link in the description. Brilliant is also offering 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks to Brilliant for sponsoring this video. So far, the best way I've found to design a game-agnostic system is to replicate Roblox's service model. For example, I created this custom service called Better Marketplace Service. It's a wrapper over Roblox's marketplace service that adds extra cool features like gifting game passes, gifting developer products, and other planned things like maybe Robux-based subscriptions instead of the currency-based ones. The basic structure of making your own service can look something like this, where you have a shared service module, a server service module, a client service module, and then some optional modules for networking for remotes, and a types module for type definitions. The shared service acts as the central hub. It should be able to execute from any run context, server or client. It doesn't have any hard dependencies on game-specific logic, and it should be able to store the shared function, data, and fields that the server service and the client service can inherit from. Now, the server service in this example is going to be responsible for things like your data storage and data store logic, purchase or receipt processing and validation, and just general authority over gameplay decisions. On the other hand, your client service, well, that's going to be responsible for maybe user interface handling, maybe client-sided feedback, sending client information or state to the server. That's what you're going to be using your client service for. And because both the client and the server service inherit fields from the shared service through something like maybe metatables, you could access everything in the shared service even if you only require maybe the server service or the client service. And then this optional network module, that's going to be storing the remote events and remote function instances if you need that for communication between the client service and the server service. And then your type module is going to export your types, as well as any pre-built instances that this system might need. Now, this pattern right here is reusable across tons of systems, not just basic marketplace logic. Diving a bit deeper into Studio, you can see I have a system defined for my Better Marketplace system. I have a system package, and this stores all of the modules that we saw earlier. So I have a client service component, a server service component. Both of these modules inherit fields from the shared service. And then I also have the network for communication between the client and the server service, as well as exporting types. And this type module also stores some assets that this system needs. Hopping into the shared service, you're going to see that this thing is going to contain things that both the client and server can use. For example, I have several signals defined here, such as an item purchase signal, a receipt process signal, and even when a receipt process fails. And these events can fire on both the client and the server, so all clients across the game can observe important monetization events. And because these signals fire on the client, that makes it really easy to build a game system. Like maybe you want to put an announcement in the chat when another player buys something in the game, or maybe some kind of UI pop-ups thanking a player for when they make a purchase, and other reactive systems that can respond to different purchase events. This shared service also contains a bunch of utility functions that can be used by both the client and the server services. And these are private functions, so I've prefixed them with an underscore to signify, hey, these are internal use only. And then this module also has some public functions which are safe to call from any run context, client or server, such as observing the Game Pass ownership of a particular player with a particular Game Pass ID, or as well as pseudo Game Passes, which is probably one of the coolest features in this system. So because Roblox doesn't support gifting actual Game Passes directly, we need to work around that. So a pseudo Game Pass is basically just a developer product, but in our system, we treat it like a Game Pass, and then we store purchases in a data store so we know who actually owns the pseudo Game Passes. And because these pseudo Game Passes are actually just developer products under the hood, that means a player can purchase it multiple times, and those multiple purchases can be gifted to other players. So as you can see in this prompt purchase function, before we prompt a player to buy some kind of product in our game, we need to check if it's a pseudo Game Pass, and if it is, we need to see who the recipient of that Game Pass is, and if that person can actually get the Game Pass. And if not, then we don't want to prompt it at all. Moving over to the server service, this is where all of the authoritative state management is happening. So when the player joins the game, the server is going to be responsible for creating a configuration instance on every single player, and that configuration instance stores information like Game Passes the player owns and purchases that they've made. And then anytime receipts are processed, maybe a player purchases something, or they purchase a Game Pass, or their subscription changes, whatever the case may be, the server service is responsible for updating the values on those configuration instances, and that way every single client in the game can observe when things happen with other players. So moving over to the client service, what I'm able to do in this module is I can actually observe those configuration instances on every single player in the game, and then just listen for attribute change signals, and then I can deduce or figure out what that player purchased, because I store a product ID, transaction ID, who the recipient was, all that kind of stuff, and that allows me to fire certain signals on the client side. Another big part of gifting is the user interface, which should be client side only. And I have a prompt gift player UI, and this UI will pop up on the screen, and it looks pretty like Roblox official UI. And that's because I copied Roblox's invite friends user interface, and I tweaked the layout and the visuals to make it look like a gifting interface. This is what that user interface looks like. So in the core UI, when you invite a player to a game, this kind of UI pops up, but it's for inviting players. I just copied that UI, and I was like, okay, I'm gonna re-script it and redesign it to be for gifting. And so I got some pretty good looking UI here, and it'll just list out all of the players in the game who are eligible to receive a gift from you before you actually purchase it. Once I actually select a player to gift, then I'll notify the server like, hey, I want to gift to this player, and then the server can do its server-sided validation to make sure I can actually buy it for that particular player, and that's basically how this system works. Now, obviously, we need to have game-specific reactions when purchases occur. When I gift something, or a developer product is purchased, or a player owns a specific Game Pass, we need to be able to code game-specific logic so those players can receive the benefits. So that's why we need to code all of that in separate modules, which I have stored under an implementation folder. Right now you can see how there are some server modules inside of the system, and a natural concern that can pop up with this server-side logic is that, hey, because those are in module scripts, can't an exploiter just see and steal the server-sided code? And yes, if you put everything in replicated storage, then that is a valid concern. Exploiters can see that code. So to mitigate this issue, my module loader has a cool feature that if you have any modules and you want to relocate those modules into a server-sided container when the server starts, then all you need to do is just set an attribute to relocate those modules to server script service. So that means I can bundle all of the logic of a system in a single folder or package for organization purposes, but then this server-only logic gets relocated into server script service at runtime. So right when the server starts, the server's like, hey, I need to relocate this. So it moves it into server script service, and then it leaves like a dummy module that just points to it in server script service. So that way require paths don't break. Now you could design this system the other way around, where instead you store everything in like server storage, and then what needs to be shared with clients can get relocated, but that gets a little bit more wonky with maintaining require paths, and the way I'm doing it right now is a lot simpler. And as far as I'm aware, clients shouldn't have access to the server logic because it gets relocated before players join the game. Now, if you believe otherwise, if you think this is still a security concern, then please let me know why in the comments below. Maybe you can use an executor and try to figure out how to bypass or somehow grab the module before it gets relocated or something like that. But because the server does it right away when the server starts before any players are in the game, I don't see this as a security vulnerability. Heading back to the implementation folder, because the Better Marketplace system is generic, it needs to know what developer product IDs are actually pseudo game passes and what to do when players own game passes or purchase developer products, like all that game specific logic. So that's why this is the game specific implementation in this folder. Basically how this implementation system works is it just requires the core system modules, and then it wires stuff up and interacts with these core modules. For example, hopping into the shared setup, this setup module runs on both client and the server. So that means I can go through some stuff in my game that's stored in a catalog, figure out which stuff are the pseudo game passes, and then register those pseudo game passes with the Better Marketplace shared service. Those registered pseudo game passes will be stored in the shared service, so I can have this setup module run on both client and the server, and it's not going to be an issue because my shared service can also run on both run contexts, and then the client and the server services can just retrieve the data from the shared service, and it's not a problem. On the server side, in the server setup module, this is where I store a bunch of the game specific logic for when purchases happen. So like, what do I want to happen in my game, this specific game, when somebody purchases a product? So I have a function in my Better Marketplace system, handle product purchase. This is basically just like process receipt, but instead it gives me the receipt info in the player, and then I just figure out which handler I need for a particular product ID, call that callback function, return whether or not it's successful, and then the internal stuff of like data saving and all that is handled by my marketplace system. And then inside of the client setup is where I do some extra user interface stuff. So like I was talking about earlier, if I want to display some stuff on the screen when an item gets purchased, I can do that. So in here, I'm observing when us, the local player, gifts to another player, will pop up something on the screen like, hey, a gift is on the way to you. On the other hand, if we actually receive a gift, then we can display another thing on the screen like, hey, a player gifted this thing to you. How nice. And so all of my client-sided logic just exists in this setup module. Because all of my game-specific implementation exists in these separate modules in a separate folder, that means all of my core system code for the Better Marketplace system is game agnostic, it can be reused in any project, and I can import it as a single package. And what I've found is that this is the power of designing systems to be agnostic. You can write the infrastructure once and then reuse it everywhere. Let's quickly look at another example, which is a tutorial system. Almost every game needs some sort of tutorial system. That way you can onboard new players, you can teach players controls, and then you could guide players through maybe their first few tasks in your game. Tutorials are often very game specific, which leads to developers having to constantly rewrite tutorial logic over and over and over because games can just be so different. So I was like, you know what, screw this. I'm gonna build a generic tutorial system or infrastructure using this same kind of model of having a shared service, server service, a client service, a network module to communicate between the client and server, and a types module. My tutorial system takes care of signals for entering and exiting tutorials, tracking tutorial state, saving tutorial progress to data profiles, notifying both the client and the server about tutorial changes, validating logic on the server side, like when a player wants to move to the next step in the tutorial, the server can validate, hey, can you actually move to that next tutorial step? All that cool stuff. And then this system also exposes you the ability to give it a bunch of custom tutorials, and then it'll just step through those tutorials for you. So then that way, in my implementation modules, all I need to do is require my tutorial system, and then I store my game-specific tutorials in a separate module. This has all of my game-specific logic inside of it. It's a lot of logic. And then all I need to do is just go to my shared setup and then just register that tutorial with my tutorial system. So inside of the game, when I'm in an active tutorial, I have all of my game-specific logic running, like some custom UI to show what you need to do for the tutorial. I got this arrow pointing, which is for this specific tutorial step. And then what the server does in this tutorial system is that it's keeping track of what tutorial I'm in and what step I'm at. So what it does is it creates a new tutorial configuration instance and it stores it in this active tutorials folder. So the server, again, is responsible for that authoritative state. It takes a clone or it copies this configuration instance, which gets returned out of my types module, and then it updates the information on this configuration instance. So it shows that I'm currently on step 2 of this tutorial, and the specific tutorial that I'm in is main tutorial. The state is currently in progress, and the player that is in this tutorial is me, Crusher Fire. So because this is an instance inside of replicated storage, all other clients could observe when other players are inside of tutorials, and that means the client service of this tutorial system can fire its events, and then you could observe those events from other systems and code whatever logic you want. So to really cement this pattern, let's build an example setup from scratch. First, we need to create a new folder for this system. I don't know what this system is going to be. I'm just going to do an example setup, so we'll just call it example. This is my example system. We're going to need a folder to store all of the core logic for this system. This is going to be the agnostic logic. I usually just call it system package. And then any of the game specific logic that needs to use the modules from our system package can be within the same folder, but in a separate folder. I'll usually call this implementation. So for our package, we're going to need a module, and this module is going to act as the shared module. So we could call this shared service. We're going to need another module. This is going to be the server service. And then we're going to need a third module. This module is going to be the client service. Now, even if you don't need a client module or a server module right away, I'd recommend creating them anyways and then have them inherit all of the entries from your shared service. So that way it's a bit easier and you can design your system with the possibility that you may expand it later down the line. In your shared service, this is where you'd want to maybe pull in some of your game agnostic utilities. So I have a set of like function utilities and module utilities that are present in basically every project I work on. It's just a bunch of useful libraries and function libraries, that kind of stuff. And then this service may have some events inside of it that will be fired across the client and the server. So we'll just have like an example signal here, and I'll make a new signal. And then to code the implementation for this signal, it should be done within the shared service. If you need to code different logic for the signal, like let's say you want to have the same signal, but the logic for coding that signal is different on the client and on the server, then you should probably just move the signal into each respective service and then code the logic there. Any signals that exist within the shared service should ideally be implemented directly within the service itself. So for my module loader, I would need an init method or an initialize function. And then this is where I would do whatever logic I need to fire my example signal. And since my shared service needs to run on both the client and the server, I need to throw my load module tag onto it so that way it gets picked up by my module loader. And then I don't need to specify run context. Both the client and the server will require and initialize this module. Now, another important thing we need to do in order for the client service and the server service to inherit all of the fields of the shared service is that this table is going to act as my meta table. So we need to add an __ index meta method and just simply reference it to the module itself. Another thing I like to do is that if you have any constants you need to define within your system, maybe that would be like tag names. I would ideally store it within the shared service itself as fields, and then you would name it with capitalized snake case or loud snake case. So example tag, this is my tag. So that way, the server service and the client service, if they ever need to use this tag for anything, they can access it because they'll be inheriting all of the fields from this shared service. Now let's hop into our server service and let's go ahead and require our shared service. And the best way to do this when you need to require other modules within the same system package, so like maybe the network module or the shared service or maybe a types module, you want to use it by relative paths. So if I want to pull in my shared service, I should require it either by the require by string syntax or using my script as the reference. So I would do script.parent.shared service, or I could do quotations, grab the parent, and we want shared service. And then for this module, instead of it just being a table, we're going to do set meta table on a new table, and it's going to inherit shared service. And because this module inherits shared service, you're going to see that we have access to example signal and example tag and all that fun stuff. Inside of here, we can also define an initialize function for the server service. And you might think, hey, hold on, wait a second. Isn't that going to override the initialize function that we just pulled in from the shared service? And the answer is no, it won't. It will add it as a new key value pair inside of this table, not the shared service. Another important practice when you're creating these services is I recommend returning a frozen table. So table.freeze module, table.freeze module, and then let's run into the client service and do the same thing. Return table.freeze module. And then in the client service, we might as well also require our shared service. Pull that in here. So /shared service, and then set meta table shared service. And on the client side, we can of course have our own initialize function specifically for the client, and we can store our own client-sided field. So maybe you want to have a specific client signal. Let me go ahead and actually pull in my module utils. So we could have our own specific client signal on the client side. So signal.new, there we go. And then on the server service, let's go ahead and just make an example server signal. And we actually need to pull in our modules utils and then do module utils.signal.new. And then the implementation for this server signal should be done in the initialize function. And likewise for the client service, the implementation for this signal should be done in the client side initialize function. And of course, if our system needs it, we can create a types module. So we'll create a new module script, call it types. And then I always like to make sure that all of my scripts are strict. And in fact, there's actually a new setting in the workspace, I believe, that automatically sets all of your scripts to a certain type checking mode. So let's check that out real quick, actually. If I go to workspace, it should be under scripting. Luau type check mode is default, but look, you can set it to whatever mode you want. So if you want all your scripts to be strict, you can hit strict, and there you go. You don't have to do the stupid comments on the top anymore. But anyways, your types module, all this is going to do is just export your types, type whatever. All your types will be inside of this module. And then if there's any instances that your system needs, maybe for cloning purposes, you could store them as children of the types module and then return them from the types module. And then in the implementation folder, this is going to be for modules that aren't necessarily designed to be required. These are just serving as setup modules. So you could have, you could have your server setup module or whatever, and this would pull in maybe the server service to do whatever stuff you need for your game specific implementation. And again, I recommend using require by path. So I'm just going to do that real quickly. Let me require the shared service. And actually not shared service. I wanted server service. Why did I pull in shared service? I want server service. There we go. See, by default, when I use require autocomplete, it's going to pull in a path like this. Don't do this, because then you're forced to have the system be underneath this specific folder hierarchy. Always want to do relative requires. So we're going to do server service. There we go. And then of course, the important thing we don't want to forget with my module loader system is that the server sensitive modules, let me select both of those. These guys need to have an attribute of relocate to server script service. Set that boolean equal to true, so that way my module loader knows what to do with these. And also throw in my load module tag. And then I'll finally make sure that my load module tag is on my client service. And then I set an attribute of client only to let my module loader know, hey, I only want this module to run on the client side. And of course, if we need to have a networking module that stores all of the remote functions and events, we could do that as well. We just call it this network as an example. And what I like to use is Slightnick's typed remotes and typed bindables if you need bindable events, but usually I just use signals. So typed remotes it is. And I have that stored in my module util. So I have type remote and I can create events, functions, unreliable events, and then I just store it in the module. And then anytime I need to access those remotes, I just require the network module. And then after you code your agnostic system, this is when you can right click it and convert it to a package and save it to maybe your Roblox account or a group. And then you can reuse it across any game you want to make. Another cool thing with packages and this folder setup is that if you need to modify certain behaviors of your game agnostic system, you can do that through attributes. You could define whatever attributes you want for your system, and then your system can read from those attributes just by accessing script.parent, and then you can change the behavior of your system that way without actually needing to make maybe setup modules. You could just change some attributes if your system is simple enough. And for demonstration purposes, once more, I'm just going to quickly create some other example setup modules. So this will be my shared setup. I'll make sure to have my load module tag on this guy as well. And then let me also make sure to create a new module for my client setup. And then I'll also make sure to throw on my load module tag and also to make sure that this runs on the client only. And bam! With this basic design pattern in place, you can build a marketplace system, a tutorial system, a quest system, maybe an achievement system or a notification system, an ability system, whatever you want, you can build it with this setup. I haven't run into any major limiting factor with this kind of design pattern. It works great. So this is the overall approach I use to build reusable systems in Roblox. I will mimic the Roblox service model, split up logic into the shared server and client services. I'll use signals and maybe configuration instances as my communication backbone. I may use the collection service and tags and observers for intuitive coding, and then I'll move any game-specific logic into separate implementation modules. And finally, because this core system is under a folder, I can convert this folder into a package, store any properties I want as attributes on the package, and then drag and drop the system into any project. Once you get comfortable thinking about designing your systems this way, you'll eventually find yourself reusing your own systems over and over instead of constantly rewriting the same logic in every new place you work on. If you have any questions, concerns, or would like to share feedback about this design pattern, let me know in the comments below. I'd love to hear your thoughts. Otherwise, it's going to be all for me. Thank you for watching, and I will see you next time.